Hi guys! You've probably heard of Big Bang, of course, the famous Big Bang Theory show. But here we'll talk about the actual Big Bang Theory that has been the subject of religious, philosophical, and scientific discussion and debate. One of the most famous and widely accepted models of the universe's development is the Big Bang Theory event that gave rise to our universe. People who have tried to uncover the mysteries of the universe's development include famous scientists such as Albert Einstein, Edwin Hubble, and Stephen Hawking. Although the Big Bang Theory is famous, it is also widely misunderstood. A common misperception about the theory is that it describes the origin of the universe. That's not quite right. The Big Bang is an attempt to explain how the universe developed from a very tiny, dense state into what it is today. It doesn't attempt to explain what initiated the creation of the universe or what came before the Big Bang or even what lies outside of the universe. Another misconception is that the Big Bang was a kind of explosion. For example, it is thought that there was a boom and all the galaxies and stars and planets just popped out of the explosion. Well, that's not quite accurate either. So the Big Bang describes the expansion of the universe, while some versions of the theory refer to an incredibly rapid expansion, probably faster than the speed of light. So it's not still an explosion in the classic sense. So, what's the Big Bang Theory in a nutshell? This all began roughly 13.8 billion years ago and is thus considered to be the age of the universe. Through the testing of the theoretical principles, experiments involving particle accelerators and high-energy states, and astronomical studies that have observed the deep universe, scientists have constructed a timeline of events that began from the Big Bang and has led to the current state of the cosmic evolution. So let's start with t equals 0 seconds. At this time, all matter was condensed on a single point of infinite density and extreme heat. Cosmologists call this a singularity. Also known as the Planck Epoch, this was the earliest known period of the universe. At this time, there were 4 basic forces in the universe which were all part of a unified force. The forces include strong nuclear force, weak nuclear force, electromagnetism, and gravity. How these forces were once part of a unified whole is a mystery to scientists. Many physicists and cosmologists are still working on forming the grand unified theory, which would explain how the 4 forces were once united and how they relate to one another. From approximately 10 to the power of minus 43 second and 10 to the power of minus 36, the universe began to cross transition temperatures. It is here that the fundamental forces that govern the universe are believed to have begun separating from each other. The first step in this was the force of gravitation separating from the other forces, which account for strong and weak nuclear forces and electromagnetism. Then, from 10 to the power of minus 36 to 10 to the power of minus 32 seconds after the Big Bang, the temperature of the universe was low enough to 10 to the power of 28 kelvins, and that is where the forces of electromagnetism and weak nuclear forces were able to separate as well, forming 2 distinct forces. With the creation of the first fundamental forces of the universe, the Inflation Epoch began, lasting from 10 to the power of minus 32 seconds in Planck time to an unknown point. Most cosmological models suggest that the universe at this point was filled homogeneously with a high energy density, and that the incredibly high temperatures and pressure gave rise to rapid expansion and cooling. At about 10 to the power of minus 11 seconds, scientists believe particle energies drop considerably. And then about 10 to the minus 6 seconds, quarks and gluons combine to form baryons, such as protons and neutrons. Since temperatures were not high enough to create new proton-antiproton pairs, mass annihilation immediately followed, leaving just 1 in 10 raised to 10 of the original protons and neutrons and none of the antiparticles. A similar process happened at about 1 second after the Big Bang for electrons and positrons. A few minutes into the expansion, the period known as Big Bang nucleosynthesis also began. Thanks to temperatures dropping to 1 billion Kelvin and the energy densities dropping to about the equivalent of air, neutrons and protons begin to combine to form universe's first deuterium and helium atoms. After about 379,000 years, electrons combined with these nuclei to form atoms, while the radiation decoupled from the matter and continued to expand through space, largely unimpeded. This radiation is now known to be what constitutes the cosmic microwave background, which today is the oldest light in the universe. Over the course of several billion years that followed, the slightly denser regions of almost uniformly distributed matter of the universe began to become gravitationally attracted to each other. They therefore grew even denser, forming gas clouds, stars, galaxies, and other astronomical structures that we regularly observe today. This is what is known as the Structure Epoch, since it was during this time that the modern universe began to take shape. This consists of visible matter distributed in structures of various sizes, ranging from stars and planets to galaxies and galaxy clusters. And this was all about the Big Bang.